Is this on? Yes. Hey everyone, thanks for sticking around all the way till the very end. But let's make it fun. I'm very honored here to present some of the ideas that I've been working on over just shy a year. Like I took a sabbatical actually and tried to think about some technical problems and try to build prototypes. And this is the first talk I'm giving where I'm trying to put them together in somewhat of a coherent story, hopefully. And so this is much more a open invitation to a roadmap than it is a product you can deploy. But before I go on, I need to have a clicker. How do I click? And then next. Right. So the concept that I will be talking about is called, or has been called by smarter people than me, delayed balanced reciprocity. It's a concept out of anthropology. At least that's where I thought it was very smart to name it such. But in our context, we will try to build an experiment, apply to these things that we'll call time tokens. And it's in social coordination rather than market mechanisms that we'll try to discuss how we can potentially use them in a technical context. And so to give a very simple definition to frame the idea for everyone and to give you a bit of a red thread to hold on to, time tokens get allocated to you continuously, but they also disappear again. And so they are not a store of value in this context. Instead, they will try to help you coordinate value together or the generation of value together. Also another preface, I'm very honored to be presenting this here on the UBI track. A lot of the original ideas are soft forked, as we were saying, off of UBI, but they're also backwards compatible. So this is applied to a technical context of peer-to-peer networking for nodes. The same machinery is still, I think, applicable in the human context as well, but we can discuss this afterwards. However, like we've been told that in order to organize society at a larger scale, we need to have money. Like Adam Smith writes in The Wealth of Nations, before money, there was only barter. But we know now this isn't true. Like, also not with the advent of agriculture. We see that for thousands of years, networks of cities arose. They started to advance technology themselves, but there was no introduction of a ruling class until thousands of years later. And we can go even further back in history, and the oldest evidence, at least that I know of, I mean, I'm not an expert on this, but the oldest social invention that we can at least prove is 33,000 years old, and it's the invention of gift giving. And so tribes, this is southern Africa, to the left is the Kalahari Desert, but this happened all across the world. People would spend a lot of their time to create jewelry, and they would travel hundreds of kilometers to go gift these gifts to different tribes that were particularly also living in different environmental conditions. And they did this to establish these social bonds over large distances so that when they would face harsh conditions like a drought themselves, they could disperse and they could go live with those tribes that they previously established relationships with. And so this wasn't a market, this wasn't an exchange of goods. This was to build and maintain those social relationships and then to rely on them if they needed as such. Right, but as I said, I'm not a historian, so you should not believe what I say. I can recommend you some books if you're interested. I have, however, for the past 8 years, I think now, tinkered with consensus mechanisms. And so the idea here is to try to take this idea of delayed balanced reciprocity and apply it to peer-to-peer networking. But before we go there, let's come back to the topic of UBI. It's a very big topic. Global poverty is an atrocity, and it's why I'm also motivated to think seriously about this topic. But let's try to see if we can reduce it to a smaller problem first. And so the question I want to ask here is, can a person earn from their data if their presence has a value in a data economy? And then the first problem that we realize is markets, as we know them and as we've been told to organize society with, they are price-finding mechanisms. But your raw data by itself doesn't have a real price. Everyone has a digital trace, but by itself, it only has a cost for collecting it. And once it's collected, it's a marginal zero cost to copy it, so it doesn't have a price. However, through scientific research that we did very intensely, we argue that if you can find ways to combine people's data streams and find ways to produce actionable information over it, that might actually have value. But then you reach a second problem, namely, what is valuable or what is valuable information? It's not just that this is a question of multiple layers of refinement to get to something that is valuable over many people. It is also a huge landscape, and ultimately it's a subjective question. What is valuable to me is not valuable to someone else. Traffic information about Boston right now is not valuable to me, whereas whether some restaurant in the area is valuable to me later tonight. And so we have to also constrain that any type of operation, any nodes, have to be free to opt in and choose themselves which data streams they think might be valuable and which calculations to try to support. Great, let's assume that we can do this. Now we have another question. We're trying to build a better world, so why would we try to hyper-financialize knowledge of all people? Information should be a public good, and it should be open for people to learn from. And so the idea of a harbinger tax has been quite popular in the community already, and it tries to balance the private ownership or the exclusivity of some good with the public interest of the community to that good. And so our proposal would be that you can have a harbinger tax on the first access to updates of an information stream. And so afterwards, the information would be fully decrypted and public, but the ones who own the data stream and pay the harbinger tax can have the first access if they can derive economic value from having this first access. We can organize these tax collections into a public fund, and these funds can be redistributed to the people that contributed the data. However, there's no need, so I drew this little circle here. Information goes in, information comes out, money flows back down. There's no need to think that these data collectives need to be trivial inside. These algorithms can be composed hierarchically. They can also even be competing inside. And more than a data collective, I actually like the word a bazaar, where people would come together and under certain rules of social understanding. So there could be rules for who can contribute which data or what data can be contributed, but also rules for algorithm designers, what can be done with the data that is in this bazaar, or even rules to whom or for what purposes the data that comes out can be used. And so this idea of a bazaar, like in a desert storm where some wise lady guards the entrance, I think it's helpful to set a first filtering on all possible data, right? But then we're not there, just as a very bland statement, no one has all the answers. So I'm not proclaiming to know how to build any of these architectures, and yet we want to have valuable information for humanity. Why are we underproducing collective information streams that people can actually use to solve problems? And I think here, to me, we can call the devil by his name. Money creates boundaries by construction, and this is not a moral judgment, more of a logical one. If you want to have markets, then you need a region where this money is enforced, and it by definition creates a region where this money isn't currently accepted. Unless we would all accept some global authoritarian currency that we will all have as a single currency. But I think that's a less interesting option. So it's not a moral judgment, it's just an observation. Nation states have done this, and we have repeated the same thing with networks like Bitcoin and Ethereum and many more. They build on a moneyless open internet, which has its own problems. But now they form these islands, and we need to try to bridge across these islands. But we already can address this problem in, we know a very powerful solution, namely very strict namespaces and typing allows you to read across boundaries. We've built this. This is called Web3. We know very precisely what Bitcoin data means. We know very precisely what Ethereum data means. That doesn't mean that I can write to the other boundary, but I can already read very unambiguously across boundaries. And so if we now want to compute something useful, we still need to organize resources. And so the question is, what is something that everyone has but is still scarce? And we do have such a quantity. It's called time. So hence, time tokens to try to organize resource usage across different domains. What is very important to notice, and I will explain this better in a few slides, and many of you knowing circles will already know, these time tokens themselves do not represent money. They are not a store of value, and explicitly the time tokens, as I said in the beginning, they will fade away out of your wallet. So there's no point in trying to put them on an exchange. It gets even more complicated than that. There's no logical way that you can think of them as money. So the harbinger tax that we talked about earlier would still be paid in project tokens that actually build out the data types, the algorithms, the interfaces that first try to solve people's problems, and they would be the value that actually funnels through the system. And again, like the time tokens are just there to orchestrate resource usage in an equal way to be able to generate this more valuable product than just raw information. So anyway, very long introduction to get to a better definition of time tokens or delayed balanced reciprocity. This slide is thanks to Circle's UBI. They've been pushing this, I would say, a genius idea for a very long time. But I will try my best to also briefly recap it. Graphic is also credit to one of their documentations. So everyone can generate a node on this graph without any constraints, but it is just your unique labeled money. And as any other random coin, if I would create an ERC20 contract, it has no value. No one's going to support liquidity for it. However, if I express that I trust any other entity to be honest and particularly non-Sybil, meaning they don't create multiple accounts. What I also do on the contract is saying that my tokens are one-for-one changeable for the other tokens, and so there's, along this connection, fungibility. If we take this property over the whole graph, then as long as there's a path between any of the two nodes, and thanks to Chris's work, I don't know if he's still here, we can try to find a path and move tokens from one side of the graph to the other side of the graph through this transitive property over the path. A very interesting feature in the context of peer-to-peer networking is that trust relations form this small world graph, which has the very attractive feature that the average distance between any of the 2 points is logarithmic in the total size, which is a property you tend to really want to have. But because it's basically randomly generated, this is quite a robust property without any specific DHT structure or other properties that you normally use in network technologies. But everything I've said about the time tokens, right now the graph properties isn't captured in the name itself, for which I'm sorry, but like this sounded really well. So time tokens additionally decay. So they are continuously issued to you, but they will also disappear back out of your wallet. Like I said, this is compatible with Circle's UBI. I think the largest difference in this implementation is that the accuracy on the exponential decay is of higher resolution in these other contracts. But on the interface, they're fully backwards compatible. The reason that I think it's interesting to emphasize and really use this property in the sense of network technology is that we can now think of the connections along the graph as little springs. So if value would move from one side of the graph to the other side of the graph, it will build up tension along these edges. And if value moves in the opposite direction, this rebalances the tension along these connections. And as also previously explained, these connections have a certain capacity, they can dry out. So you can even like stop, like value will at some point not be able to flow if it's too unbalanced. But by discounting them, you have a natural cleanup mechanism. So if nothing else happens, you will remint new tokens in the origin node, and the nodes that got scattered, they will exponentially decay away. And so you have a natural property that history is kept along for the ride, but not too long. And if nothing particularly happens, then it will just, like little springs, come back to a rest state. Thank you for bearing with me for so long. This is the last slide, but it's an important one. So I hope to still have time. I don't know. There's a timer. So I've talked about also, if you remember, like at the beginning, if we want to think about this huge landscape of informational landscape of what to compute that's relevant for someone, it's quite an ambitious goal, right? And in particular, like you have to imagine now that nodes are talking about particular topics that almost no other nodes will be talking about, because we definitely cannot do the Ethereum or Bitcoin full replication model. So you already have to start at the lowest level where you're reinforcing the peer-to-peer network so that you can protect yourself against abuse of resources. And so here's where I propose one first application of these time tokens. Namely, if you see this picture on your left side, I made a little drawing of a social graph of the nodes. And imagine that far away, these blue nodes, they try to request, they send request messages over peer-to-peer network, but they try to request this from the red node. What we can now do is, first of all, at network speed, they can just send these requests, but instead, we can ask that they attach a payment intent. And so an intent here is understood in the sense of like house swap solvers or ANOMA intents that are executable cryptographic messages, but that then need to be combined by some computing algorithm to actually execute them in a more efficient way. And so we have these two behaviors happening at two timescales. Nodes can communicate at network speed to each other and request resources from somewhere else, but they have to attach these payments intents. We can allocate these, solvers can try to solve the aggregated paths and rebalance the actual time tokens that move across the network. But if now some portion of the network tries to disproportionately ask more resources from any other region of the network, then it is your friends that actually will protect you. because at some point their channels to you will get drained and the connection is emptied out, at least temporarily. And it's in their interest to make sure that they're not connecting to any inhonest node. And so the proposed dynamic behavior that you would see is that there's this domain wall that forms. Like any bad actors that try to ask too much resources from the others, and here this is relative to how much flows in the opposite direction. This domain wall, everyone has an interest to push it as close as possible to the actual bad actors. And I think together, so there's a theoretical paper that's called the Brahms paper, together with another piece of work, I think this can give you a Byzantine fault-tolerant peer-to-peer view, which is a necessary first step to even try to consider a network that is computing various things where most nodes wouldn't know what the other nodes are actually talking about, but still want to be able to assist this. Anyway, sorry, I'm a little bit out of breath. So the idea was that we can make it very explicit that these tokens decay, call them time tokens, and instead have them implement this concept of delayed balanced reciprocity. We try to showcase that this might be helpful in a peer-to-peer network to orchestrate and balance resource usage such that you have a local measure of Sybil resistance, which is very powerful to build on. But by themselves, they don't have any intrinsic value. So the reason to use your time tokens well would be to get other people, or other nodes in this case, to actually collaborate with you on data that you might find interesting and interesting computations over that data, such that you are part of generating valuable information that would have a market price. And on that, we could propose that a harbinger tax funds access to the first updates of that stream and then pays back down to the whole tree of contributions. Anyway, I've skipped over like dozens of topics that that you should ask me. I'm very happy to chat offline or in the time that remains. So I want to thank like Circles UBI, also the conference organizers. Two friends in particular have been very helpful in figuring this out. And then Stefan, I don't know if he ever hears this, for the desk in Lisbon, and many for feedback. Thanks.
Thank you so much. So we're a bit over time, but since our next speaker is on his way, we have time for questions. If anyone has questions, please, the floor is yours. Do you have any of your own questions you want to answer? Because you said you skipped so many. Or do you want to talk about like soul-bound tokens versus time-bound tokens? Maybe, since that's a hot topic of late.
Well, soul-bound tokens and time tokens are probably at different layers of the stack here, but there is something to be said that if you would have a way to organize your data. I've not talked about privacy, by the way. Privacy is very important in all this architecture, but for simplicity reasons. If you want to have interesting soul-bound tokens, you'd probably want to generate zero-knowledge proofs against some commitment. And if you have an architecture that could hold your data trace throughout life privately, but then you can make proofs against that trace or those commits, that I think can be much later work, but quite interesting. Yes. Thanks.
Anything else? Anything on the screen? Daniel has one.
So what makes your time tokens tick? So what kind of time reference do you use? Is it, can I imagine it as real time, or is it some type of logical clock?
No, this is real time. I can go deeper into where relative time is important, but maybe we should take this off offline. So an important point to mention is this is not trying to compete with layer 1s, layer 2s. The observation rather is we have solved for double spend and the ability to do negative reputation. So the idea is that a lot of this work is implemented as contracts on layer 2s, where we already know how to solve this problem at a reasonable scale, and a lot of smart people are working to improve that. So there we have a measure of global time that you can refer to, and as such, it's also implemented.
Okay, thank you.
Thank you. Thank you so much for your time,
Thanks.
Ben.